Hello and you're welcome to the Big Tech Show with me, Adrian Weckler, the tech editor of the Irish and Sunday Independent. This week we've got something completely different for you. What is the multiverse? Are we living in one? Are we living in a simulated reality? Elon Musk thinks we are. Lots of scientists and philosophers keep talking about it. I've gotten into rabbit holes on YouTube about it. I'm going to talk to a quantum physicist right here in Ireland. Dr. Mark Mitcherson, recently appointed assistant professor in quantum science at Trinity College Dublin. Mark, you're welcome to the podcast.
Hi, thanks.
So we've seen this in every science fiction movie franchise over the last couple of years.
Right.
We've heard it from billionaires, we've heard it from scientists, and sometimes I do wonder whether there's a version of me out there who is a billionaire or a mass murderer or a talking frog. Can you give us just the idiot's guide as to what we mean when we talk about a multiverse?
Sure. Yeah. So I guess when I think of the idea of a multiverse, there's at least two kind of completely different ways in which this idea comes up in physics, right? Okay. So one of the ways in which it comes up is in study of the universe as a whole, all right? And this is called cosmology. So there's some scientists that are interested in understanding like the history of the universe, where it comes from, and so on. And there are some theories in cosmology that say, well, the universe is actually kind of composed of many different kind of disconnected, separate universes that have their own laws of physics. Okay. Now I'm not a cosmologist. Okay. So I actually not such an expert in that area. What I think you're talking about and what I'd want to talk about is the other kind of multiverse that kind of arises and is relevant for what you were just saying, which is the idea of many worlds, the many worlds of quantum mechanics, it's called, right? And this is the idea that essentially every time, you make a decision, you flip a coin, right? Instead of it just being heads or tails, both of those possibilities actually exist, and they separate into two separate universes that kind of exist in parallel. Okay. And they're all real. You just can only experience one of them. Okay. And that I think would be the kind of idea underpinning what you just said. That means that there would be another universe in which you are a millionaire, another universe in which, perhaps you're dead, another universe. I'm not sure about you being a frog. I'm not sure how that would work with the laws of physics.
Well, why not? Why, if I can be dead or a billionaire, why can't I be a talking frog? I mean, because the laws of evolution may have taken a fork somewhere back in another universe. And if there are an infinite number of parallel universes, let's call it that, based on forks on everything that happens in every split decision we take. Right now, for example, I'm deciding to say one thing, but had I just decided to say another thing to you, that would have led to something else entirely. Maybe we would have gotten into a fight. Maybe I would have threatened to kill you, maybe something else would have happened. So I suppose I could be a talking frog somewhere.
Right. Yeah. I see what you mean. I guess it kind of raises questions about what does it mean to be you in a parallel universe, right?
These are ideas that are very, very difficult for us to get our head around in general, aren't we? And I know one of the criticisms of this whole area, as indeed maybe could apply also to early periods of quantum physics and science, is that it's difficult to know where the scientific authenticity and respectability of all of this starts and finishes, because so much of it isn't provable in a lab.
Right. Yeah, that's a very good question, or a very good point. So yeah, I mean, I think a lot of physicists tend to take a kind of pragmatic view on this, right? So yeah, I mean, maybe I should take a step back and just say, I mean, this idea of many worlds of quantum mechanics, okay, it's usually considered what you could call an interpretation, right? Or it's almost in the realms of philosophy, right? So there's some people that really believe in this many worlds, okay? There's some other physicists, who absolutely vehemently oppose to it, and they don't think it's true at all. When it comes to actual physics, things that we can measure in the lab, we all agree. I mean, there's no question about quantum mechanics. There's no question that it describes every single experiment that we've ever tried to do to test it with exquisite precision. Okay. So this question about whether there are many parallel universes or not is kind of, let's say, somewhat philosophical. So in that sense, I would say there's not really, I mean, there shouldn't be a problem, right? As long as we all agree that, there's some parts of science which are about measuring things. And then there's another part which is just kind of about maybe a bit more speculative, a little bit more, let's say artful, a bit more about just kind of trying to understand what the equations mean. And that's where this kind of slight arbitrariness comes in. But you could certainly criticize it for not being rigorously experimentally testable. But I think that it's still fun to talk about, right? So that's would be my take on it.
It absolutely is, and that's why we're talking about it today. I mean, one of the big questions would be, well, who cares if there are parallel universes? Why are we even investigating this? I think there are interesting philosophical, as you describe it, reasons for doing so. For example, Elon Musk famously said a couple of years ago, he reckoned that the chance that we're in a base reality. Now, he was talking about this idea of a simulated multiverse or simulated reality, or us being in a simulation. He said the chance of us being in a base reality, the true reality, he said, is 1 in billions. In other words, he's sort of alluding to an idea that we're actually, what you and I are part of right now is essentially one giant big quantum computing video game. Let's call it, for simplification. But he also said that we should hope that that's the case, because it means that if and when we eventually annihilate ourselves, right, through either war or ignoring the climate or whatever it is, that civilization won't end, that thought won't end in the universe, that there actually will be a continuation of sorts because we were only in a simulation in the first place.
Right. So
I realize we're getting very deep for this podcast, by the way.
No. I mean, this is all good stuff. I mean, so okay. First of all, I'd say, I mean, Elon Musk likes to make provocative statements, right? So whatever his estimate of the probability is, I don't really think he has any rigorous way of coming up with those numbers, right?
Well, he is a rocket scientist. You know the way people say, well, he's no rocket scientist. He is a rocket scientist.
That is true. He is a rocket scientist,
and he learned it in about 6 years.
Right. But I guess what I would say is, okay, so, I mean, I understand where he's coming from. I mean, what he's basically saying, right, is that if we accept the idea that there really are sort of uncountably many different universes that exist, right, then all it takes is just, for a very small number of those universes to evolve into intelligent life, and an even smaller number of those, aliens or intelligent life organisms to decide that they want to try and kind of simulate reality. And then, I mean, just one of those species doing that, you would assume that they would do millions, trillions, however many different simulations. And so the actual number of kind of simulated universes would vastly exceed the number of real universes that had intelligent life. And that's a fair argument. I mean, I think he may well be right. I'm not sure, though, if it's necessarily true that we should be hoping that that's the case, right? Because there's another argument that says if we are living in a simulation, okay, then the simulation is only useful to the guys running it if we don't realize that we're in a simulation, right? It's like the Truman Show, no? I mean, the Truman Show ended when Truman realized that it was a TV show. So there are some people that argue that we should really stop talking about this altogether in case the aliens realize that we're in a simulation and they switch off the computer.
Well, I mean, the same point was made on Neil deGrasse Tyson's podcast. There was a comedian, Chuck Nice, I think his name is, and he was saying maybe that's why we can't travel faster than the speed of light, because if we could, we'd be able to get to another galaxy. And to which deGrasse Tyson came in, so before they can program it. So the programmer puts in that limit to stop us reaching that point of enlightenment. Maybe the Matrix is another example where the character that betrays Neo and all of the others and Morpheus, he's having a stake with Mr. Smith, and he says, I know this is all a simulation. I know that I'm really just some cadaver being farmed somewhere, but this just tastes and feels good and real to me.
Yeah, ignorance is bliss, he says. Yeah, absolutely. Right. So maybe we'd actually rather stay in the simulation rather than find out what's actually on the other side. That's true.
Blue pill, red pill, all that stuff. All of that. That's kind of been politicized, that metaphor. It's kind of a bit of a nasty one these days. But we've been talking about the many worlds theory. I mean, there are a couple of different theories. I was swatting up on it before I came on. There's this idea that that space is infinite, and that there are the idea of universe bubbles that actually crop up, and which form the seeds of new and different universes. Not always, as you alluded to before, by the way, observing the same laws of physics as ours. I think that maybe gets into string theory, does it? I was watching some of the YouTube stuff from Brian Greene and Sean Carroll and some of those American physicists on this. I just couldn't understand it. I don't really understand string theory, but as far as I can tell, you're getting there into the absolute ABCs of what makes up physics, and there can actually be different types of physics.
Right. Yeah. So as I already said, I'm not a cosmologist or a string theorist, so I can just tell you my take on it with a bit of a caveat that I'm not doing research on this myself, right? But I mean, the thing about string theory is, as you say, it's kind of trying to be the most fundamental theory of matter. So something that would really unify all of the description of the fundamental forces with gravity, with all the particles that we can see in our particle accelerators and so on. Okay. But string theory, I mean, it's a very beautiful framework. It basically describes all the particles as being little one-dimensional objects like pieces of string, and they're vibrating. Okay. And they have different vibrational frequencies, and those different frequencies basically tell you what kind of particle the string corresponds to. So if you zoom in on an electron, you actually see that it's like a little violin string that's playing an A, right? And then if you zoom in on a proton, you'd find it's the same little violin string, but it's playing a C instead, if that makes sense. Now, the problem with string theory is that mathematically speaking, it doesn't actually make sense as a physical theory unless we don't live in a universe with just 3 dimensions, up, down, left, right, forwards, and backwards, plus the time dimension. Okay, so that means we have 4 dimensions. Actually, you need, I think, either 10 or 11 dimensions to make string theory work. Which I guess you were going to ask how does that make
so
sense?
Already my mind is blowing up. I mean, look, I find it hard. I'd say, like a lot of people, even to imagine the basic big questions that we have, such as the concept of infinity, like even the idea that space might be infinite. And we're trying to marry that alongside the idea of a big bang. So space and time, I actually don't really understand what space and time is in that context. I don't understand how there could be infinite space. And I don't understand how there could be an end to space either, because the question is, what's on the other side? Right.
Yeah, I mean, look, I'll be perfectly honest with you. I think I'm not sure I understand the answer to those questions either.
But like, for example, the Big Bang, this idea, and what everybody always says is, well, what was there before the Big Bang? And a totally legitimate question. I remember listening to Brian Greene, American scientist, quantum physicist, had an interesting analogy. He said, look, maybe we're asking the wrong question when we say what was there before the Big Bang. I mean, maybe time itself is actually a property that starts or that started, which, again, I can't really get my head around. But he used the analogy of a traveler traveling north on Earth, and you get to the North Pole and he wants to travel north. Where does he go? It's the wrong question. There is no more north. Right. So like these big questions, sometimes I wonder whether we're equipped to even be, talking about this or wondering about it. Obviously, smart people like you are. I'm not.
Well, but that's what I was going to say, right? So, I mean, sometimes
you were going to say that you were smart and I'm not.
No, what I was going to say actually is that I don't understand things really either in the way that you're talking about, right? So I actually think, I don't know, personally, my progression as a physicist trying to understand these things, a big part of it has just been coming to terms with what we actually mean by understanding something and what it's actually reasonable to expect to be able to understand, right? And I think there's a lot of things out there that we can predict, we can measure, we can understand them using science, but we don't necessarily get this kind of really tangible sort of understanding, like visualization, that I think we crave as almost, as animals. That's the sort of understanding that we feel the most comfortable with, that you can actually visualize something like, a ball flying through the air, taking this particular trajectory. This is something that we can all understand. We can express it in equations, but we can also see it happen. Now, the laws of quantum mechanics, the kind of the history of the universe and cosmology, these are things that we will never be able to really perceive. And so I think we have to kind of revise our expectations about what it means to understand something. That would be kind of my take on it.
We're certainly having a bash at it. I mean, if you look at any of the big science fiction franchises I mentioned at the top of the podcast, I mean, the Marvel universe is all into the idea now of multiverses and parallel universes.
Right.
Spider-Man, who was quite a significant theme there in the last two movies. Loki, the Marvel series, has just finished on Disney Plus. That's without giving away any spoilers. There are lots of different Lokis from lots of different potential timelines there. Right. I listened to a charming book by the British novelist Matt Haig. It was read by Carey Mulligan, the actress Carey Mulligan. It's called Midnight Library. And that had a version of the multiverse as well. It was the idea that this is a person who was feeling depressed and she tries to kill herself. And there's this thing called a midnight library between life and death. And she is shown the different realities that she could have been involved in had she done something different in her life. And she's invited to live those realities to see if she's happy in any of those before she makes her final decision. So in terms of a popular and a populist idea, I do think that the idea of a multiverse and parallel universes, it's got our creative juices flowing. We're starting to think about it and see it an awful lot more now in popular fiction and storytelling.
Yeah. No, that's true. I mean, I've heard about. I mean, Loki is one that's actually on my list that I wanted to watch because it's related to this many worlds theory of quantum mechanics, right? That's my understanding, that you have these many different timelines. I guess I mean, the thing about the multiverse is I mean, they sort of have to be, if we really think of the idea of a multiverse, they're different universes. That sort of implies that they really have to be separated, right? So in some sense, it's always going to remain in the realm of, fiction and philosophy, in the sense that if we actually were able to find a way of crossing over into another universe, well, I don't think it would actually be a different universe, right? We'd have just found a new part of the same universe that we're in. But it's still a beautiful idea. I think everyone would like to be able to imagine that there could be, a better version of themselves out there somewhere. But
and we haven't even gotten into the thorny subject of what would happen if you met yourself in that. Let's say it was only a very slightly different universe and you met yourself pretty much as is. Like, would you trust yourself? Would you be friends with yourself? I used to think about this a little bit, and it's a good way of reflecting on what kind of a person you really are yourself and what you might do differently. I would recommend Loki, by the way. I think it's the best one of the new Marvel spin-offs. I quite liked WandaVision. Wasn't crazy about the Falcon and the Winter Soldier. So I think Loki is the best one. If you're thinking about watching that, I would say definitely do it. There are a couple of Irish connections here to this. Erwin Schrödinger in Dublin in 1952, he gave a lecture where he warned his audience that what he was about to say might seem lunatic, but he said that when his equations seemed to describe several different histories, these were not alternatives, but all really happen simultaneously. He called this superposition. There are a few other bits I wanted to get to. I'm not sure we'll have time. There are a lot of criticisms of the idea of multiverse or parallel universes, and you've alluded to one or two of them. I found an interesting one in quite an old New York Times piece in 2003, because I think a lot of this really became popular in the early 2000s. I think it was Nick Brock or Nick something or other who released a paper on this. There was a lot of talk about it at the time. But anyway, this guy, author and cosmologist Paul Davies, he says, for a start, how is the existence of the other universes to be tested? To be sure, all cosmologists accept that there are some regions of the universe that lie beyond the reach of our telescopes, but somewhere on the slippery slope between that and the idea that there's an infinite number of universes, credibility reaches a limit. As one slips down that slope, more and more must be accepted on faith, and less is open to scientific verification.
Extreme multiverse explanations are therefore reminiscent of theological discussions. Indeed, invoking an infinity of unseen universes to explain the unusual features of the one we do see is just as ad hoc as invoking an unseen creator. The multiverse theory, he says, may be dressed up in scientific language, but in essence, it requires the same leap of faith. I think that's reasonable.
Yeah, that actually fully agrees with what I think I really wanted to say about multiverses in general. So, I mean, in my opinion, the idea of a multiverse, maybe it's correct, right? But as we've already said, right, we can't, at the current level of technology and understanding, we can't really test any of these things. I think in some sense, it's almost the most philosophically lazy position that one can take when interpreting a scientific theory, right? Because, I mean, if we go back to what you said about Schrodinger, I mean, that's very interesting, because that was probably Schrodinger was one of the first people, I think, to really express this idea of the many worlds theory of quantum mechanics. It was just people that came on kind of later on really took what he said very, very seriously, very literally. And that's what we now call the many worlds theory. So what Schrodinger was talking about is this fact that in quantum mechanics, we can have these kind of bizarre states of superposition where you have two seemingly contradictory possibilities kind of occurring at the same time. Okay. However, we know that if we actually try and, if we open the box and see if Schrodinger's cat is alive or dead, right, we always find it to be either alive or dead. So one of the two kind of contradictory possibilities, we only ever see one of them and not the other one, right? And this is the famous measurement problem of quantum mechanics, right? That we basically have this fundamental randomness in our description of nature, okay? And the idea behind the many worlds theory was just to say, well, let's just take what quantum mechanics is telling us really literally, okay, and say that these two different possibilities, they really do exist at the same time, okay? And they continue to exist even after you yourself, you open the box or you do the experiment to measure which one of the two possibilities has happened. But what happens is that you yourself enter into a superposition state as well. So now you have your cat that's alive, both alive and dead at the same time. Okay. And you've now opened the box. And so now you're in a superposition also of being alive. Well, sorry, of having seen the cat alive and dead at the same time. It's actually a bit more complicated. I mean, it's something called an entangled state, which I don't necessarily want to get into because that's a whole other kettle of fish. But the point is that it's somehow a lazy position, because essentially, I mean, rather than try and explain why we see this randomness and fundamentally what's going on in quantum mechanics, you just kind of say, well, let's just take the equations at face value and just assume that everything is always happening at once.
It's also a good excuse if somebody says, why didn't you do that? Well, I did in a parallel universe. Right. It's only in this one that I didn't do that.
Yeah.
I'm actually a great guy.
Yeah.
You want to see what I've achieved in those other universes.
Sure.
Unbelievable.
Yeah. It's not my fault you're in the wrong universe, right?
Exactly. Yeah. So anyway, look, this has been a really, really interesting discussion. I suspect that we're going to be talking about this for years to come because it's a big idea and it's interesting and it's fun, as you identified at the top of the podcast. It's a fun thought to go through the different possibilities of what is out there and what might be, and whether we're living in a simulation, whether there are other universes, or whether it's all just something to get us talking and thinking. Anyway, Dr. Mark Mitchison, recently appointed assistant professor in quantum science at Trinity College Dublin. Thank you very much for joining the podcast this week. And that's all I have time for. So from me, Adrian Weckler, the tech editor, the Irish and Sunday Independent, I'll talk to you same time next week. Bye-bye.